in this big room. Before I start, my name is Jane Yan. I'm a program manager in the Windows file server. And in the past few years, I've actually seen a very steady increase using iSCSI in general as a choice for SAN storage. And why? And IDC did a research in asking people why they want to choose iSCSI as a SAN storage, and the two main big drivers behind it. One is low cost. And given our current economic environment, low cost has been a very big advantage over other solutions there. And the second one is really easy to deploy and manage. And what I mean by that is because the iSCSI rides on the Ethernet network, so you don't need to have additional infrastructure to deploy it. And also the network admin are familiar with the networking knowledge there so that they are more comfortable with managing the iSCSI network. So actually, yesterday I was talking to a customer in the booth. He was trying to move from a fiber channel storage environment to iSCSI because exactly those two reasons. And he has seen a huge reduction in his costing for deploying that environment. So that's what I'm here today, talk about the Microsoft version of the iSCSI software target. So what I'd like to go through the session with, talk a little bit about SAN storage. So before I talk about it, I want to see show of a hand. How many people are familiar with SANs? Okay, I can fly through that slide then. And then focus more on what Microsoft iSCSI target is and how do you deploy it. And then the biggest thing is that with this release, we're making it available for production environment. So I want to share with you some of the deployment scenarios and considerations that you want to think about when you, before you put it in the production environment. And at the end, I want to do a few demos on how you can build a highly available iSCSI software service. So I'm going to fly through these slides, talking more generally about the SAN compared to DAS. So you know about having a SAN storage give you two advantages. Basically, you have a pool of storage now that can be shared across all the application servers. The advantage is that now you get a better improvement on the storage utilization, and also in the case where you want to build the Windows failover cluster, which requires shared storage. So and you cannot just build two standalone DAS storage to build the failover cluster. Of course, you can use the replication, but that's a different story. So with that, at the high level, and then I'm going to ask for a show of hands that how many people are familiar with iSCSI in general? Quite a few. But I'm going to illustrate for a couple of people here that with iSCSI, there's basically three objects or three terms that you need to familiar with. One is the iSCSI initiator. So at the bottom of the slides, I have a application server and a storage device. With application server, it can be SQL, it can be Hyper-V. It runs iSCSI initiator. And what this is the consumer for the storage that's provided by the storage device. The UI on the right-hand side is the iSCSI software target MMC released with the 3.3 package. So in this target UI, what's interesting about is you have two objects. One is called target. What target gives you is the connection point from initiator connect to. So when you're on the initiator side, when you configure that, you select the target connecting to. Once the connection gets established, what you have is the virtual disk object that associate with the target object get exposed to the initiator side. So from the disk management UI, on the left-hand side, on the iSCSI initiator, basically you will see disk 1 and disk 2 shows up at local storage. So that's the iSCSI in general works. There's a few variations actually. So if you're not using the Microsoft, there's other ways of you can assigning storage to initiators. Some iSCSI devices ask you about what virtual disk get associated with which host. So they bypass the target configuration. So they remember the sort of masking and unmasking information, if you're familiar with the fiber channel world, within the virtual disk device. In the iSCSI software target for Windows, the mapping between the virtual disk and target to initiator is done through the target object. So that's kind of the difference between the Microsoft version compared to other implementations. So with that, I'm very happy that we released the software, made it available on the download center. For people who are familiar with the history of iSCSI target, they may know about this has been a storage server release in the past few years. And we really want to make it available for the Windows server, because now we see a huge trend in virtualization, and the iSCSI target can play a big role in that market. And in the later deployment scenarios, I want to share with you some of the configurations that I've seen customers doing with the iSCSI target. And we released the package on April 4th, beginning of last month, and we already seen over 10,000 downloads, and we've seen very, very good feedback about this release. So we're really happy that it's made it to the public, and I hope you will be able to get hands-on and try it out. So now I want to switch to talk about what Microsoft iSCSI target is and how to deploy, configure it. So as mentioned earlier, people choosing iSCSI for two main reasons. One is low cost. The other one is ease of deployment and management. These are still true for the Microsoft version of the iSCSI target. And it even more so true that in the low-cost case where you just literally have a Windows server, and that, with the iSCSI target, it turns into a storage device. So you don't really have additional hardware required as long as you have the Windows server and, of course, the network. So that's where it's very easy to deploy and manage, because with this iSCSI software target, we provide the MMC UI, so it's very familiar Windows user experience. And we also have WMI and PowerShell. So the new PowerShell commandlet in the 3.3, which I'll demo in a minute, that gives you this not only managing it locally, but you can also manage remotely. The last point I have here is about interoperability. So iSCSI software target is iSCSI in general actually is an industry standard. The target is the implementation of the RFC 3720. So in general, we can interop with any iSCSI initiators that comply with the standard. And in fact, in our test lab, we have a list of third-party hardware initiators as well as software initiators that we test with. As a side note, actually, yesterday I'm talking to a customer who has mentioned to me that he had a VMware environment where he was using the iSCSI software target in that environment, and he had no problem with that. So when you download the package, what you actually have are two MSI files. One is the iSCSI target MSI. By the name, it implies that you install this package on the iSCSI target server. And what this gives you is a whole bunch of components that runs on the target. The main service that's going to help translate the I/O onto the VHD is the WinTarget service. And then I also have a box on the right-hand side shows cluster resource DLL. What that means that the iSCSI target in this release can be run on a Windows failover cluster. And later on, I'll demo how does it look like and what does it mean to provide the highly available iSCSI target service in the production environment. And all the other boxes on the top of the wind target are related to the management. 2 boxes are highlighted. One is the MMC, the other one is the PowerShell, which I'll do a demo in a minute. The right-hand side corner, there's a local mount driver. So this feature is about if you've taken a bunch of snapshots, if you have, like, say, 2 SQL server on the left-hand side, and you want to take a VSS snapshot because that's an application consistent snapshot. And once you've taken that snapshot, you want the backup server to be able to back up everything, back up the snapshot from a centralized place. And that's what this local mount driver comes in handy. What it does is that you will be able to mount the snapshot to the local server, so expose it as a drive. And then the backup server will be able to just back up the data from that drive instead of the backup server goes into each application server. So the other component here matters is the iSCSI initiator. The highlight here is that every single Windows box comes with a built-in iSCSI initiator. So even the client and all the server SKUs has it. So it's very easy to bring it up and run it. And then the I/O just flows from the application, goes onto the initiator layer, and then I missed a couple of boxes to reduce the complexity, but actually goes onto the network driver layer, and then it goes down to the other side. The Windows target server will pick up that I/O and look at the package, and then write or read depending on the command. So I mentioned there were 2 MSI packages. One is installed on the server side, and then the other package is installed on the client side. What that gives you are 2 components. One is the VDS hardware provider, the other one is the VSS hardware provider. So after that, then the management I/O goes from the providers to the target service. The VDS provider is used when you want to do management remotely using a VDS client. So a couple of inbox VDS clients are disk RAID and storage management for SANS. So those 2 will be able to manage the iSCSI target remotely by you can run it on any of the application server. The second provider is called VSS hardware provider. This provider allows you to take VSS snapshot from the application server. So this is, for example, when you have the SQL server, as I mentioned before, because SQL writes transactional I/O to the database. And when you take the snapshot, you want to tell the SQL database and say, hey, I'm about to take a snapshot. You need to freeze your I/O. And this is when the VSS framework gets providing that kind of interaction between the application and the storage provider. So in this case, like iSCSI target plays just like other storage hardware device. And that provider will, when it gets a chance and say, hey, now you can take the snapshot, it goes off to the target side and take the snapshot. And once it's done, it reports back as successful. So this is basically what the package provides you and where you're going to deploy it in the environment. So now I'm going to switch to my demo and show you how to manage the iSCSI target. So I have a iSCSI target here. Once you install that MSI, you're going to find this the snapping in the all programs administrative tools, and it's here. And I also open up a PowerShell commandlet console by clicking on this icon. So the first thing you want to do is import module. And you need to remember the name. It's Microsoft iSCSI target. What this is basically making the commandlet that allows you to manage the iSCSI target available on this machine. So once you import the module, what you can do is there's a whole bunch of commandlets. You can do get commands dash module to see what, oops. didn't see it. I may have the wrong one. Okay, so if you type new and you start tapping, you can start seeing what the command lists are. There's new, there's set, iSCSI, and there's get iSCSI commands. So here I already have a target object created, and I have a whole bunch of virtual disks created. So what I'd like to show now is what I'm going to create a new iSCSI target. You just give a name. Now you can see the ID, the name, and this IQN, which is the identifier for the iSCSI target. And let's go to the console. There it is. If you look at the properties, what's interesting here is the initiators. So with each, as I mentioned earlier, with each iSCSI target object, it needs to know which initiators can access me. This is kind of form of security so that not everybody on your network can use the storage unless you tell it this device can access me. So how you assign it through commandlet is that by set iSCSI and dash initiator ID, there's four mechanisms you can assign an initiator. You can do it by IQN. You can do it by IP address. You can also do it by DNS hostname, and you can also do it by MAC address. The recommended way typically we're recommending with IQN because it's unique and because it doesn't require any other dependencies. For example, if you do it by the host name, then it requires the DNS server to be there to resolve the name. And in some cases where we've seen in our environment where DNS is not responding correctly, then you're not getting the right connection there. So with the iSCSI initiator, you can get the name by launching this iSCSI initiator from the control panel. Once you get here, you go to the configuration tab, and here's a long name that representing that initiator. So I have copied here to a notepad. Then I'm going to do a paste. Oops. Not getting it. Okay, here I can tell you another trick. If okay, here it is. Oh, I forgot to tell it the name. And then say this is what you want to overwrite it with. So another trick is that I've seen people when they're trying to testing the connection from the target initiator to the target, and they're not getting right the connection. In many cases, the assignment is not right. So one thing you can do is to assign IQN with star, which means that I don't care the initiator identity. Anything comes in, want to connect me, I can do the connection. It's not very safe, it's not very good for production use, but when you're doing testing and just trying to make things work, that's the trick that you want to remember. So now that I have a target, once the initiator logs on the target, it doesn't have any devices, so you still don't see any drives showing up. Now we create a iSCSI SCSI disk. Okay? So with this, you got to give a path. So I have a folder that I created here. Want to use it for the hosting my VHD. And another thing you want to give it is a size. You can give the number and then give the unit. It can be KB, MB, GB, TB. So now I have the VHD. You can see the files being created, and also here is the third disk mapped to the path that we just specified. So here you have the drive. And now you need to give the assignment to this initiator saying this target associated with this VHD. So that's by adding the mapping with the target name and a path for the VHD. And that you will be able to show here. Here we have the target maps with VHD, and now also the initiator can connect to it. So here's my initiator. I'm going to do a refresh. Hopefully it will pick up the other target. So this is the target that we just created. And once you connect to it, then what you see here is so a few things about this one. By default, it just picks up any local adapter. If you have multiple IP, or if you have a specific network you want to use, network path, what you need to do here is to pick this special initiator adapter, and here you'll be able to see a list of IP that available for use doing the iSCSI connection. So in this case, I want to just use the default one so that it's easier to connect. And the other point I want to call out here is that if you have a DHCP environment, if you specify a initiator IP or target IP, and if the IP changes, then you're going to have connection problems. So what you want to make sure is that if you do use DHCP, first of all, we do recommend static IP so it doesn't change. But if you do use the DHCP, you've got to make sure that, think about when things not working, then you've got to check for the IP addresses. So once it's connected, this is my initiator, then hopefully we'll see a new drive showing up. And here it is. So it's just like pretty straightforward and simple to set it up. And so going back to and here you can do the, we created the target and we created VHD, then you can do get iSCSI target and see what's the, it will list out all the properties and the target associated with the properties. Okay. So now we've gone through some basic management and configuration for the iSCSI target. Let's change the gear to think about if you want to use it in production environment, what do you have to consider and what are the scenarios this iSCSI target can help you with. iSCSI target, software target leverage the Ethernet network, and also it stores the data in the storage. So a big part of deployment consideration are your network settings, your network configurations, your network infrastructure, and then also the storage, what you're going to use actually to store the data. So the first thing, there's no particular order, so I just listed a whole bunch of things I want to talk about here. The bandwidth. In theory, iSCSI runs on every bandwidth, even tried on wireless, it works. But of course, in the production environment, you don't want to do that. As a best practice, we recommend 1 gig and 10 gig so that you provide enough bandwidth for your application to run on. And the second one is about dedicated or shared storage. This is really, think about when you have shared storage, the problem is that it's easy to predict other workload getting into on the network and causing it to congest. And actually, one of the customers yesterday were talking about he observed some iSCSI disconnection when the network is really heavy. So what we suspect is that because iSCSI initiator and target keep doing pinging to make sure, are you still there, are you still there? And when your network is very congested, that ping message doesn't get across. So the target thinks, oh, my target is gone. Let me disconnect and try to figure out later. So when you have a very congested network, your packet transfer is not guaranteed there. That's why if you have a dedicated network, you could isolate the traffic such that for better troubleshooting and analysis. MPIO is also a feature that you need to enable on the initiator side so that you can provide multiple network links from the initiator to the target. The TCP offload is a network adapter setting. So what this does is basically offload the network stack onto the adapter, and helps to reduce the host CPU usage. So that makes, if you have a Hyper-V environment, for example, so the host CPU can be more, there's more resources to make available for the application workload. iSCSI offload now is taking the TCP offload one step further. You're not only offloading the TCP stack, but you're also offloading the iSCSI stack, and that also helps with the CPU host resources. Jumbo frames is another network setting. Basically, if you have, by standard, is 1,500 bytes every TCP package. Now with jumbo frames, you can use about 9,000. You set it to 9,000, so every package can be much larger. So you're going to reduce the processing related to every packet. With the storage, what it really is about is the performance, because after all, your storage is the hardware devices are the parts that store the data. And in a lot of the performance issues that we seen customers run into is about there isn't enough disk spindles, like literally disk hard drives there to provide that bandwidth. Because especially with the recent capacity growth in the hard drives, now it used to be 100 some gig per spindle, and you have to deploy to support the capacity. You just have enough bandwidth there. But now with higher and higher disk capacity, then now you only have like very few disk drives there. So with the 15K RPM drives, it can service about 200 to 250 IOPS. And if you think of like how much IO your application requires, that gives you an idea on how many spindles you need in that deployment. Disk rate is about protecting the storage, but another side effect is actually very much related to performance. Later on, I have some data to show actually in a specific workload how much disk rate can differ from RAID 10 configuration, for example. So as I listed here so that you can think about not only what kind of protection you want to have for your data, but also what the performance impact are associated with that configuration. So with the security aspect, CHAP is a standard authentication protocol that's mandatory for the iSCSI as a standard. And also Microsoft iSCSI Target support CHAP as authentication mechanism. So there you can set up basically both ways. Let's go back to my demo here. So here is where you, by default, it's not configured, but here you can enable it both ways, give a username and secret, and you can do it forward and reverse. So not only the initiator have to authenticate against the target, the target has to authenticate against the initiator as well. And from the initiator side, when you do the connection, here is where you need to, if you have the CHAP enabled on the target, here's where you can specify the logon secrets for both. And IPsec is the encryption protocol on the Ethernet network. Because iSCSI leverage Ethernet network in general for the encryption, that's why it also works on top of IPsec to enable the data on the wire. So next, now we talked about the things that you need to consider for your deployment in production. And next couple of slides, I want to show a few scenarios that we have seen customers deploying where iSCSI Target has been helpful. So the first slide I have here is the storage consolidation. In a small environment, let's have an example here. I have a Exchange server and a SQL server and a Hyper-V server. So because right now they all have DAS storage, and they all dedicate storage, and if I have Exchange server not using much storage, and my database in SQL server, on the other hand, has been growing pretty fast, but because they're not shared, so I can't really say, hey, give me some storage over here. So now if you do a storage consolidation, putting a iSCSI backend as a SAN storage, now that all the application data can service through this pool. So this is actually a general benefit for SAN, as I talked about earlier. And from the client perspective, you can see it doesn't really know any change. It just accesses the data the same way as it's been migrated before. And also taking the storage consolidation forward, there's also the virtualization case, where just focus on the application server side. Previously, you can have a fiber channel deployment. Each server will connect to the storage array using the HBA, and that could be expensive if you're adding on the cost. And another point I'm not illustrating very well on the slide is that those fiber channel arrays can be different from different vendors. So you got to administrative using different tools, using different management mechanism, so it can be pretty complex to manage. Where if you virtualize your storage, where you're putting iSCSI target server as a gateway, so you basically consume all the storage from and providing that pool to all the application server. There you have a sort of a uniform environment, and you can manage through a single point. And also it's providing the storage through the Ethernet network, so there you don't have all the HBA installed on all your application servers. So that's another reason we see why people using storage virtualization using the target. As I mentioned earlier, we released iSCSI target because we see a huge demand in Hyper-V. So I want to focus a little bit more on how iSCSI target can play in the Hyper-V environment. I have a very simple setup with single Hyper-V host, single iSCSI target. So in this configuration, what I'm doing here is that I provided the iSCSI storage to the Hyper-V host. And there the VM store the data on the host storage. This is nice, very simple to set up, and the host knows about the storage. It manages the storage. And if you try to expand for HA for the Hyper-V host clustering, you just add another server, and there you have it. In contrast, I have the same hardware setup, but have a different way of assignment. So in this one, I have iSCSI target acting as a shared storage for the VMs. So if you notice, the difference is now the host doesn't know about the storage at all. iSCSI actually, in fact, is the only way you can do VM guest clustering. So where your VMs, now you want to provide the HA at the workload level. In case that one of the the VM goes down for patching, for management, you still want to provide that workload through another VM. So what you need to do now there is the VM guest clustering. And using iSCSI target, you can have that set up right there. Another setup we've seen is now, especially with R2, it supports Hyper-V host HA, meaning that you can cluster the host and do live migration across the nodes. So this is the setup at a very high level. You have the iSCSI target providing shared storage to the Hyper-V host. In here, that basically is very similar to the single standalone, but now you're providing the shared storage to a cluster, and the Hyper-V host now can cluster using the iSCSI target. So one side note I want to touch on here is that I illustrate the cluster using shared storage with MPIO, and so the interesting side effect is that when we released iSCSI target 3.3 in April, we had a release note saying initiator as a cluster with MPIO is now supported by iSCSI target 3.3. I want to make a point here is that was a mistake, and we correct that the TechNet article saying that it is in fact a supported environment, and this is the setup that you would have if you want to use it. So now with this setup, what you have is that I have not only the host clustered, I also have a dual redundancy at the network level. But you probably will ask now that, what about my iSCSI target? It is still a single point of failure. What I can do to provide redundancy at my storage level? So this is the HA solution that we are presenting here. So I already talked about the host clustering. I also talked about the network redundancy. I want to focus about the box here. In this configuration, I have two Windows servers setting up a Windows failover cluster, each running iSCSI target. So iSCSI target is capable because it's plugged into the Windows failover clustering framework. You can create a virtual resource group that providing the iSCSI target. And at the back end, you probably will ask, well, Windows failover clustering requires shared storage. So what I can do as the shared storage? So in this case, you do need a hardware shared storage as the back end. And in most cases, it comes with the dual controller, so it protects you from the controller failure. And then you have multiple disks set up with the RAID configuration so that you can protect yourself against the RAID failure. And in this case, also from the target to the storage, you can run MPIO so that you have multiple links from the target to the actual array. The point is here I want to make is that everything within that yellow rectangle is the HA solution. You can actually purchase a hardware configuration from our hardware vendors that comes with the multiple servers and dual controllers, and then they have a SAS array as a backend storage. So because of the Hyper-V environment is what we focused for this release, we made a lot of effort in testing where is the scale. So I listed the backend configuration, and on the right-hand side, what we're trying to do is that we had 8 Hyper-V hosts, each running 10 to 12 VMs. And within each VM, we have an instance of SQL I/O running, simulating a SQL workload. And then we have the iSCSI target as failover cluster, and how we measure our scale and how we pass the failover criteria is that if we do a planned or unplanned failover at the iSCSI target level, all of our VMs, as well as the application, will come back after a temporary store, but none of them will have an error showing up. So that's what we're trying to provide the HA experience for applications such that when you need to do a failover at the storage level, it provides that redundancy. Your application will not experience any I/O error. And the scale we were able to achieve is 92 VMs. And I'll do a demo later to show that experience. So another workload environment that we have looked into with iSCSI target is network boot. How many people are familiar with SAM boot here? Okay, I see a couple of hands. So I'll spend a little bit of time on this one. So how iSCSI target has been implemented to support this feature is developing a feature called differencing VHD. What it means is that you have VHD that from the initial side can write to, but it will have a parent, which is a read-only copy VHD that it can see, it can read from. So in the boot environment, the base image would be your OS image that you want to boot from. But because of each machine has its own identity and other things that you want to write to, it will write it to its own differencing VHD. So why you want to do network boot? In general, it's very fast because Windows deployment comprise of you have to make a copy of the installation files and then do the customization. With this deployment, you don't have to do those copy of the files anymore because it's already there, and you're deploying it across the network. So each of the machine can read from that base image and then just go directly into the customization. And we have pretty good boot numbers that I can share in the next slide. In terms of quick recovery, is because now that none of the machines has local copy of image, if someone fails, you just replace with the new hardware and point to the right target, and then there you go. You can have up and running it pretty quickly. The reduced CapEx and OpEx is because each OS image, thinking about Windows 2008 R2, what we see is about 15 gig of OS image storage. Now that if you have 100 of them, you have 1.5 terabyte of storage just using to store the OS images. With the differencing VHD, you have one copy for 15 gig, and the rest of the customization in the differencing VHD, what have been noticed is about under a gig. So there you have 150 gigs when you have everything set up. So that's like more than 10-fold of reduction in just storage size, and that translates into the power and cooling and management costs as well. And also because you have a control of the base image, you can control, or the admin can control what goes on to that base image, whether it can be applications you want everybody to use, and then if somebody installs something else, then you can redeploy that pretty quickly. Yes? So the question is that possible to boot Hyper-V host machine without that VM, without that VHD live on the Hyper-V host machine? Oh, so you're trying to boot VM using iSCSI? Yes. Yes. So the answer is, in theory, yes. Practically, I haven't tried it, but I heard it's possible to do it. The only thing you got to watch out there is that when you configure the VM, you got to make sure your network adapter supporting PXE boot. So maybe I'll spend a little more time here is that there is a number of ways you can do diskless boot. One is using iSCSI boot-capable NICs or HBAs. So that's considered to be hardware solutions doing iSCSI boot. So each of the machine has a card, whether it's NIC card or HBA card, it can do diskless boot. It knows where to talk to, where to go to get the target, so it mounts the OS image to the client machine. The second one is called software boot. What that means is that your NIC card is just any PXE boot NIC card. And once it's loaded, you tell it to download a copy of software loader. So open source one will be gPXE, and that's where actually we tried it in our HPC environment in our testing. So once you download that copy of the image, that loader will be able to bootstrap itself and then knows where to connect to the target, and then it mounts the OS image on the target, on the initiator, and then everything boots up from there. So the case that we focus on in this environment is the HPC boot. So within HPC, what happens is it needs the deployment very quickly, because typically it comes with a job. You need to deploy the entire cluster of hundreds, can be even to the thousands. And the utilization of the HPC cluster closely tied to how fast you can deploy. And with diskless boot, we're bringing down the deployment time from days to hours. So this is what we have measured in the HPC boot. We focus on two set of cluster size. One is 128, the other one is 256. We also test with different RAID configurations. And here is an example I was saying earlier about how RAID configurations matters your performance. So in this case, you can see we, in RAID 10, compared to RAID 5, deploying the same amount of cluster node almost had 40% of reduction in time. And also, when you're deploying 128 compared to 256, you double amount of computers, but you didn't double the deployment time. So that's where we think the boot scenario is really interesting, and we're trying to figure out a way to see how this can be leveraged outside of HPC environment. Actually, I have a blog on the TechNet that talks about how you can do it sort of in a testing environment in a small scale. So now let's go talk a little bit about how you can providing shared storage to the clusters. So another good use case actually I found with iSCSI Target is really good with demo. In this case, I have a laptop with a number of VMs, and one of them going to be the iSCSI Target VM, and forming a cluster with another 2 VMs. So in case you're wondering whether iSCSI Target can run in the VM configuration, the answer is yes, because when we actually release the product, there are certain criteria that we have to meet. One is being that how measure the performance difference between the iSCSI Target running on the in a virtualized environment and in a physical environment. And when we did our testing back when we releasing the iSCSI Target 3.3, the differences is not very big. I think it's about 10% difference that we measured. So another demo I want to show later is that I want to show that the iSCSI Target in the HA environment can provide transparent failover to the application servers. Yes.
For the VMs that are using iSCSI, is there API in place now to utilize iSCSI offload from cards on the host?
The question is that if there is any API.
Is there a method yet? Is Hyper-V expose iSCSI offload for use by the VMs?
Hyper-V. Sorry, I'm not sure I understand the. Yes?
Expose physical iSCSI offload cards to the individual guests so they can accelerate.
Oh, okay. You mean if there is any, that's actually, I think, is very much so on the networking card. And that one, I haven't seen any card that expose Hyper-V offload directly to the VM. I've seen it more on the Hyper-V host machines. So here what I have is a cluster, and I have initiator connected. So I have a cluster here using the shared storage that provided by this initiator, by this target. What I can do is I want to add another cluster disk to this initiator. And you can see how it's going to pick it up. I already configured this target, which had a disk associated with it. What I need to do now is on the other machine that I need to connect to the same target so that it be seen by the cluster as shared storage. Since I already have it there, I need to do a refresh so that it can, okay. So here's an example of, because I only assigned the target to one of my node, so the other node actually can't pick up the target. So what I want to do is I want to add another one. So here the warning is basically saying, now that you have multiple initiators connect to the target, and then you're about to share the storage to multiple nodes. If the initiators are not in a cluster environment, you may run into a corruption because each of the machine trying to access the drive, unknowing other machines are accessing the same drive. But because we have iSCSI initiators are set up in a cluster environment, so we can safely say, yes, that you can assign it. There I do another connection. So when you come back here and see a disk image, you'll see this drive is being assigned. Because it shows up as SAN storage, there's a new policy in R2 saying everything need to, first time it's seeing it, it should be showing as offline to prevent data corruption. There I wanted to bring it online and initialize it. And that, you can come back to the iSCSI target, the failover cluster here, say I want to add storage. So here, because it's now is a shared storage and it can be seen by both nodes, it will be able to pick up by that at no time. So now you have added additional storage as shared storage to the clusters. So the second demo I want to show here is, anyone familiar with Diskless? So I'm configuring Diskless here as a workload, and the database shows on F drive, which is a iSCSI disk. Because I already configured, then I'm going to move forward. So once the test is running, let's take a look at perfmon. I have perfmon highlighted here as the disk read and write on the iSCSI LAN. And because of my storage is coming from a cluster, I want to show a failover. So right now, the owner is iSCSI in one, and let's move to another one. So as you can expect it, as the target server moving from one node to another, it's getting brought offline from one node and then bringing online on the other. During this transition period, the application will not have access to the storage. Okay, now it shows that it has been brought online on the other node. Let's see if the initiator can reconnect, and hopefully then the I/O will be resuming in a short time. It's taking longer than I hoped for. Yay! Now it's all coming back online. So from an application perspective, it sees a stall during this the brownout period, but after that, everything comes back. So one thing I want to call out is because I have a really tiny small laptop, so each my VM has 512 meg, so it's barely running. So this is why it's taking a lot longer than you probably will see in the production environment. So one other thing is, let's check out the system log. So because I had this disconnection when I'm doing the failover, you can expecting iSCSI initiator will say, well, I'm not able to connect to the initiator. And from a application server perspective, ESE is the JET database engine trying to writing exchange data to the application database. It does not see any error. It just see a brownout time and then reconnect. So that's kind of the HA experience we are providing through iSCSI target server in the production environment. So if you want to have application running iSCSI software target, and if you have HA is your critical requirement, this is a configuration that you need to think about. All right, with that, actually, I want to open up the floor for questions. Yes. Yes. So actually, Let me do a demo here on how you can do that. So I have the initiator here. And there are two things you need to do to enable MPIO for the Microsoft DSM. One is that you need to go on the server manager to enable a feature. Now it's taking fairly long time. Okay, maybe when I can just talk while it's coming up. So one thing, the first thing you need to do is go into the server manager with the MPIO feature. You enable that, and then you need to go to a control panel. There is a MPIO commandlet, control panel panel. So if you type MPIO in the control panel, you will see the configuration. And what you need to do is go to the second tab page, and there is a checkbox saying adding iSCSI device support. So you need to check that checkbox and then reboot the server there. And then you will be able to have multiple connections. And then from the user perspective, you will see a one disk device, even though you have multiple paths to the same drive. So yeah, so that is how you're going to configure MPIO. Other questions? Yes?
The MPIO is hardware specific, like you've got QLogic HBA will not work with that.
So MPIO is a feature that supported, it can be either from Microsoft DSM or it can be from the third-party DSM. So that iSCSI target, from iSCSI target perspective, it doesn't really care. It will be able to plug into the stack and then leveraging different features. But of course, I'm sorry? Yeah, exactly. Can you do any remote snapshot between two targets? I understand. So the short answer is no. The snapshot is only available to the local iSCSI target. One thing we are thinking about is that you can probably do a snapshot and do a backup, and from the backup server you will be able to create a disaster copy for that, use that for recovery. But from a target perspective, if you're asking about whether you can do replication between the two targets so that you can have a more DR-ready setup, the answer right now is no. Yes? Sorry, I didn't catch the question.
No, it's not. It's only chat.
Sorry, what, you mean any other authentication method are supported other than CHAP? So yeah, no, right now iSCSI target supports only CHAP for the authentication. That's the industry mandatory. Thank you. All right.
You were mentioning MPIO there before. MPIO has to be installed both on the initiator as well as the target. So if you've got a Windows 2008 server talking to a Windows 2008 server with a target installed, it has to be installed on both, right?
So let me go back to the slide. Actually, it probably helped with the understanding on the where you need to install the MPIO. So in this one, so MPIO is basically allows you to have a view to the disk, even though you have multiple sort of link to that view. And what happens if you don't have MPIO, each time you log on to the target, it presents the device, and the initiator will think of, oh, that's the LAN that comes to me. And then if you log on another time and then say, oh, there's a second LAN that comes up to me, and it doesn't know, okay, this is the backend, it's actually the same. So with MPIO, what it does is that now it actually see this, although there's multiple view to that disk, it is actually one disk. So that, and with that, it provides a single view to that disk, and so it doesn't have multiple sort of view to the same hard drive, the same iSCSI LAN. So in this configuration, what I show here is that your initiator have getting the storage from the iSCSI target because you have MPIO between the initiator to the target. So you got to have the MPIO installed on the initiator side. And then, because also you have the target consuming the storage from the backend, and if you have multi-path from the target and the storage array, then you got to have MPIO configured on the target to have that single view through multiple channel. Does that help answer the question?
Yeah, I think so. What about the MPC? You can support as well. Like there's two options. You got MPIO. If you look at the initiator.
Oh, MCS. Okay. So the difference between MPIO and MCS is that so whenever iSCSI establish a connection, it makes a session first, and then it builds the connection on top of the session. So with MPIO, it's actually multiple sessions. So every time you make a connection, it's a session established. With MCS, is that you have one session established, but you can make multiple connections from the initiator to the target, and then it can utilize multiple network paths. So with iSCSI, with our iSCSI target, we support MPIO and not MCS. Yes? The release for the iSCSI target 3.3 is supported on all SKUs for Windows Server 2008 R2, standard, enterprise, and data center. So we actually released iSCSI target in storage server release multiple times. So even back in 2003 R2, storage server had iSCSI target 3.0, and then 3.1, and then 3.2. So all the prior version of iSCSI target are supported within that storage server release. And it's only the 3.3 that now you can run in production specifically on 2008 R2. No, it doesn't work because with the 3.3 has special APIs that talks to the trying to manage the storage that's only available in R2. I'm aware of a couple, but I don't think we are recommending one or another. I think it really depends on your price range and your configuration need. I think there's what you can search for. I think what I've seen as an example, I've seen HP StorageWorks has that configuration. Basically has controller servers and directly attached to a SaaS backend as shared storage. Yep.
I think the cheapest way you could do it is using a SaaS-based SAN.
That's what we are think. Yeah, that's what we're seeing as well.
You could have a fiber channel SAN design there. I think back when 2003 was out, the storage server, that was the way to get iSCSI into your fiber channel SAN, was basically to have the iSCSI target storage server in front of it, and then your fiber channel, you had that gateway. So doing that, you could do that too if you have your fully fiber channel on an iSCSI gateway. You could do that right there. For free. Yeah, you're consuming cluster, yeah.
Okay. Yep. Any more questions? Yes. I heard some performance tools. I haven't. Yes. Oh, I see. So it's specifically talking about network boot deployment. Is that the question? So that is something we are working on, because from a target perspective, what it really means in supporting that scenario is about we have the difference in VHD feature so that you can have the benefit of storage reduction when you're trying to boot a large number of clusters or computers in general. So there is so from a target perspective, we have the PowerShell, we have the commandlet to allow you automate that process. What comes actually when we're trying in our test lab, what comes challenging is that if you want to deploy large scale, like if you want to do iSCSI hardware initiator as a boot capable NIC, for example, or HBA, how do you actually configure those and pointing to the right target? So that part, I'm not really sure what kind of framework or APIs that the network, the hardware provides to allow you for such automation. In the software loader case, what we find challenging is that you can have that software loader either available on each of the diskless client, like via USB or a CD. So you burn an image and then everything boot into that image. You configure that the software loader pointing to that target with the IP and with the port and everything. So you can do it by that way, but the whole end-to-end, like providing that software loader and those things, you pretty much have to do it yourself. Another way we were thinking about is that for large scale, you may want to have DHCP in that environment so that it helps with the configuring where the initiator can get the target information. But then we were kind of having trouble finding like if there's any scripting automated way to configure that DHCP. So the challenge is that the whole configuration of your network and where your software loader could be, those part is not uniform or straightforward, I would say. So from a target perspective, yes, we provide all the scripts and in WMI or in PowerShell to allow you to configure the base, you already have the base image, so creating those different VHDs and assigning them to the targets and creating those targets, assigning the targets to the initiator, all that part, you can do it pretty easily with PowerShell. Okay? Yes.
Sorry.
Yeah, no. I'm
With the clustering, since both system is accessing the same shared storage, is there any issue with synchronization of the data?
No, because that's actually what the Windows failover cluster provides, is that it allows a single node access the storage at any time. So when you do failover, what happens is kind of a transition of the ownership of that node from one machine to another. So from application perspective, because it will just have a timeout on the I/O at the TCP layer. So the TCP will remember, okay, this I/O hasn't been received by by the target yet. And when after the connection reestablished after the failover, it will just retransmit the packet.
Okay, so no data in transmission will be lost then?
Shouldn't be. If it is, it should be something we need to fix.
Is it active, passive, or?
Yeah, so the term is actually active, passive, and dual active, what means that you can have multiple target resource groups. But at any time, one node will own that target. So in the concept, it's actually active, passive, but because you can have multiple of the target resource group, like literally or conceptually, it's more like a multiple iSCSI target server within that cluster. So there's another term also, we call it dual active.
So it can be dual active then?
It can be, yes.
So that would help with your I/O essentially if you have dual active at the front, and then you could have multiple initiators going against the targets at the same time and then going back against that set. So then you're going all passing through one.
Right, so yeah, so it does work that way. But the way I kind of think about it is that if you want to make sure, especially in production, and one node fails, you want to make sure the other node can handle the load. Otherwise, you have a good setup for everything runs well. And when the failover happens, you overstress one node, then you bring down the entire cluster, then you may have trouble with that.
Have you only done two? Have you ever tried active, dual active with a passive node? In other words, that one sitting there? Like active
Yeah, we have tested that. It's basically from a target perspective, it's two instances of iSCSI target running on clusters.
It's like you're worried about your fail or the load. So let's say you did that, you had active, but you got a third one sitting there ready to go if one of them died.
Yeah, so that way you can have better utilization with like 3 node, 1 like active, passive type of configuration.
You try to geographically disperse?
No, because we didn't really play too much in the replication. Like if you have a geographically dispersed cluster, you got to have replication on the back end. So we haven't really like tried out any third-party replication software to see which one really works that way. So yeah.
Each target is stored as a VHD, so when you create one, it's a VHD file. Is that how it is?
Yes. So on the target server side, there's 2 objects. One is the target object, which is the servicing as a connection point from which initiator can actually connect. And then the back on the actually virtual disk object side, you associate with that virtual disk to the target object, so that it basically gets serviced through that target. And the backing of that VHD object is a VHD file.
So what happens if you did you're talking about snapshotting before, what happens if you did a VSS snapshot of the VHD file and then like doing a disk shadow? Instead of that VHD file or the snapshot as a disk drive later on back that.
So let me actually show you this one. With iSCSI target, actually comes with a feature called snapshot. So what the snapshot does is it basically, on the target side, you can initiate a snapshot of all your VHDs. So what that gives you is a crash consistent snapshot. What it means is that because it doesn't really know when the application, it doesn't have a mechanism to tell the application, say, hey, I want to take a snapshot, and you got to hold your I/O for a period of time when I'm taking the snapshot. So what effectively from the application server perspective is like this VHD is just been effectively you crashed it, and that's the state where that VHD is. So it doesn't guarantee you any application consistency. So what that means when you have a database, SQL database, for example, when you try to mount that backup, it will do it's a dirty shutdown database. So you have to do certain rollback necessary.
So it's going to be downtime.
Sorry?
It's going to be some kind of downtime.
So it really depends on the state of when you're taking that snapshot, and depends on how much rollback you have to do. So there may take a little bit of time. It's not a clean shutdown database, basically. If you do it from target side, that's why in recommendation if you have the application database workload running on the initial side, we want to recommend for a VSS snapshot from the application server, because that one gives you a application consistent view for the database or. Exactly, yeah. With the VSS provider, that's what we play in part of the VSS snapshot framework.
So I'll be using the Equalogics, the software they provide with Equalogics to do my snapshot instead.
If you have a iSCSI SAN, like Equalogic, for example, it will have a version of VSS snapshot. And so then when you're taking snapshot, you invoke that VSS provider talking to the VSS SAN, Equalogic SAN, to take the snapshot. Yeah, so the name we named our provider as in VSS, like hardware provider, and VDS hardware provider is where we actually see, in the context of storage devices, we turning that Windows server into like a equivalent of hardware storage device. So that's why we named our storage provider.
Anyway, software, whether it's Linux or
Yeah, I mean, it's software package, but it's kind of in the context of what that array is fitting in the overall deployment. That's why how we named it.
So to get the concept correctly, if I want to do failover cluster with Hyper-V, I have to be talking to the VH directly from the SIM, as opposed connect the iSCSI connection from the Hyper-V server, then access the file from the Hyper-V server. Am I making sense?
I'm lost a little bit there.
Hyper-V server right now.
Yeah.
There's one connection to the iSCSI.
So you have a Hyper-V host talking to a
Basically, and that drive, that's where all my VHD file is
hosted on.
hosted. Yeah.
Okay.
So basically, the iSCSI connection has to happen first before my all my hosted server go live, or whatever I'm running on top of it. All my VM before all my VM go live, the connection has to happen first.
Oh yes, definitely, yeah, because you basically, with your host connecting to the target, what it shows up on the host is that you have a whole bunch of drives. Almost like if you look at from disk management earlier, it's almost like your local hard drives. And then, yeah, you got to have those hard drive present before you can turn on the VMs, because that's where the actual data is hosted on.
You guys ever try, this is what something like, you have a VHD file, can you put a copy of the VHD file and then sort of attach it to target?
So your question is more about whether a Hyper-V VHD can be loaded with iSCSI target and vice versa.
Yeah, that'd be one scenario, but the other scenario would be if you had an old server or had storage on it. I don't know, it could be anything. Let's say a file server, for example.
Mm-hmm.
Let's say 2,000 files on it, but it was old and you just wanted to get rid of it. You could use like sysinternals disk to VHD, take a snapshot of that VHD file, and then copy it up and then present it for archival purposes.
Yep.
With that to another target. Can you do that?
So VHD is actually a standard format. iSCSI target can load VHD 1.0 format.
So if you have a hard drive which has files, can you make it a VHD?
Yeah.
Yeah, you can create this big and huge image.
Yeah, you do sysinternals disk to VHD, you just run it on there, and you click on what you want. It runs on the running machine, and then let's pump it onto a disk somewhere. Really another disk if you're done.
Yeah.
I do that all the time. You can take a box and pump it onto a VHD file, and then basically you can after the take that file and then put it on the user, and there you go. I just thought that was the one advantage the Microsoft one, is that you actually could take something, old storage that's sitting around, and you could literally take it and then just do a disk to VHD and then copy the VHD file, attach it, then you know how to get rid of the file server and then
Yeah,
to a virtual file server.
that's a good scenario. Actually, I haven't used the disk to VHD tools myself, but if they turn out the VHD following the VHD 1.0 format, it is something iSCSI target will be able to load and servicing to the initiators.
You could literally have another Hyper-V file server sitting there, so you could
You can have the VM actually as the initiator and then connect to the target and get that VHD content and servicing that content in through iSCSI. That's a good scenario.
Question: This PowerPoint, are they available online to download?
The what?
PowerPoint you're using for this presentation?
The
PowerPoint.
the PowerPoint. I have no. I'm not. Yeah. If you come to the booth in the TLC, I can give you a copy if you want. Yes. Yes.
On the chatbot application, you said there was a username and password, but when you showed it, there was no username.
It's
yeah, she didn't
but the options were name.
Secret.
It's a secret.
Yeah. Well, there's a username, there's a secret. So I didn't set it, but I mean, if you let me. So what? You mean this one? So this is on the target side. When you configure the iSCSI target, you can say, I want my target enable CHAP.
Yeah, on the target side, you have the username.
Yeah, so when you check that, then you can set the username and then the secret.
What do you have on the client side?
So on the client side, when you do connection, so when you do the connection, you go to advanced, and there you have the enable CHAP.